All right, so good morning, everybody. I'm Vincent. Oh my God, what's happening? Okay, so today I'll be presenting my conference papers. The topic is robot 3D scenes reconstructions. I don't know what's happening, but anyway, using a fixed field of view LiDAR-based deep camera, I will be giving some background first, then sharing the experimental result from this study. Then I'll talk about some further experiments and future work. Okay. So the background for our study is that in Singapore we have the Smart Nation initiative, maybe similar to many other countries like Canada, the state or European countries. Under these Smart Nation initiatives, the concept of smart digital city is gaining prominence. But in fact, may not be a very new topic. We see there's a growing momentum, okay? So people and the industries and academics to use more automated and intelligent technology for fast, accurate reality captures for buildings and infrastructures to support their 3D modeling. And their purpose could be from different perspectives. For example, like analysis, okay, structural assessment, and optimization of the build space from the individual building scale or to the urban level. So these technology would produce a lot of values. For example, like the legacy or new building digital documentations, or civil infrastructures or transport, smart transport grid, also surveying and urban digital twin, etc. So an emerging trend is that, sorry. So an emerging trend in this field is that there's more and more research that leverage robotic platform with advanced sensing and AI algorithm to improve the qualities of 3D data acquisitions and the semantic model reconstruction. So a few examples you can see on the left-hand side, like drones, and bigger drones or smaller drones, and different kind of ground robot equipped with the sensing devices for the reality capture and 3D modeling. But one of the research challenges relevant to civil or the built environment professional is that our scenario usually is like a clutter and GPS denied settings where the surfaces are weakly textures, as you can see on the right corner. So there are a lot of clutter and a GPS denied scenario where the robot, when they navigate in these built environments, then they may have encountered the difficulty to consistently navigate in the build space. And this may affect the 3D mapping and data capture. And also there are a lot of weakly texture components. For example, the wall are blend white color. So this would affect the data registration and downgrade the quality of the point clouds and the 3D data. So there are in fact some research or study in this domain in the automation in construction, these journals, and using advanced robotic system with a sensing device, like using unmanned airborne vehicles or ground robots for the reality captures. People also in use of LED robots for scanning the construction site and building interiors. A more recent one actually in Georgia Tech's also study the robot spatial behavior or social navigation on the construction site while capturing the 3D data. And one of the research questions is that there is currently lack of a standard or how we should integrate this point cloud data quality or the sensor perception into the upfront 3D mappings or the robot navigation process. And as a result, this could possibly optimizing the scan data quality, okay, aid the robot navigation and the 3D mapping. So this is one of the central tasks, but we don't see too much research in this field. So that's why in our study, for this conference paper, we undertake a very preliminary experiment. Our purpose is to test out two sites. One is for the robot, especially the ground quadruped robot, and see if their flexibility could enable more efficient scanning for complex indoor environments. And the other one is that we try to test out the low-cost LiDAR, which is a fixed field LiDAR with $1,000, then see whether it has the capacity to produce qualified point cloud. Yeah. So, so for rest of the presentation, I'll briefly go through the experiment result and then some future works. So for the methodologies, and we trying to bundles our own handheld scanning system. It's a LiDAR-based stick camera, okay, a low-cost camera, and then it will be integrated with the tablet, okay. So inside it has the SLAM algorithm to do the 3D mapping and reconstruct the 3D point clouds. So we mount this device on our robot dogs, and then we let the robot dog navigate, okay, in the in one of the use case, okay, which is our center. And inside this experiment, we actually use human to control the robot to take out the capability of the the navigations. So here is some of the scenario or the experiment design. This one is actually the beam model for our center, and the robot starting point, let's say, is in the corner, and then there are some clutter like chairs and table and some other robot, etc., inside the center. Then we design a very single loop, and then let the robot control the robot to walk around, and then when the robot walk around moving into the scanning viewpoint, they would stop and they would actually head up and head down to scan different part of the structure because of the livid field of view of the LiDAR cameras. All right. So upon scanning of one locations and then capture the point cloud for one surfaces, then they will move on to the next plant viewpoint and then repeat the scan, etc., and so on and so forth to scan different part of the structure. But again, I want to emphasize this experiment, this preliminary testing, we actually use a manual operator to do the control. So here are the some of the capture data, and we actually compare the completeness and the accuracy of the point cloud against with the laser rangefinder and also the terrestrial laser scanner, which produce more high quality data captures. So from the point cloud, the first observation is that we see a large area of blend, which are the black color. These are the uncaptured area that cannot be fully scanned by the robot dog, partially because of the limitations of the field of view for the LiDAR camera. And the other one is actually because of the robot's navigation. It does not systematically factor in the accuracy or completeness criteria upfront in the viewpoint planning process. But we also see some promising result, which is the accuracy side. These low-cost LiDAR camera also produce quite good, I would say decent, okay, data that comparable to the laser rangefinder. And in another study we compare with terrestrial laser scanner, the quality is also quite decent. The collected point cloud, I think one of my slides is missing. Okay, anyway, so the collected point cloud are also used in another semantic segmentation study to check whether the point cloud quality are good enough for the segmentation, and it works well. So this one actually further triggered our further experiment in this field. We used the LiDAR scanner and then developed the multi-agent robotic system, and this time it enables the automations or autonomous navigation capacity. So the two innovation here is that we're trying to coordinate the drones and the ground robots in indoor scanning. So in some cluttered environment where the ground vehicle cannot move in, they would actually send command to flight the drones for indoor scanning. So there are some coordination between multi-robot scannings. And the other one is that we systematically formulate the field of view for the LiDAR scanner and then code that as a part of the robot navigation. So this time we no longer have the human operator to control, but rather it will follow the viewpoint planning and doing the autonomous navigation as well as the motion control, etc., to do the 3D scannings. Yeah. So as a result, the scan data we see is much, much better, and the completeness and also the accuracy has got improved from the manual scanning process. And from our segmentation study, the quality of the point cloud are decent to support the downstream tasks like scan-to-BIM, etc. Yeah. So I think this is the summary for my presentation. So in this study, we quickly text out the ground robot with the LiDAR scanner and whether they are capable to capture good or decent point cloud. And the answer, I think, is yes. And two of our ongoing work is that we trying to move to a 3D LiDAR equipped with the ground robots to accelerate the 3D scanning. And the other one is that we leverage the domain adaptation network to do the 3D segmentation. So this one is to address the domain gap between the mobile laser scan and our existing data set from the terrestrial laser scan or BIM derived data set. Okay, so I think that's the end for my presentations.